first thing I want to do is just position how and why AWS built services around this particular problem space, and then we'll get into a little bit more detail about what services we have for natural language processing, for gaining understanding about what is in the written word, and then we're going to spend most of the time diving into one specific service, which is called Amazon Comprehend, which is our main natural language understanding service. Like all AWS services, Comprehend does work in concert with other AWS offerings. So we'll talk about it in the context of other services as well, but most of the focus will be on Comprehend. ML at Amazon, you probably heard a little bit about this in the first session of the day. So a lot of what Amazon does more broadly with machine learning and artificial intelligence is intended to improve, simplify, or accelerate the experience that we provide to customers. And as far as natural language understanding goes, it very much fits in that category. So we would like to be able to understand how customers feel about us from what they write. We would like to be able to understand what customers mean when they speak or write to us. So this includes things like managing recommendations through the course of review evaluation on the Amazon website. It also includes, of course, things like natural language processing within systems like the Amazon Echo and the Alexa voice service that underpins that. So there's a lot of ML and AI activity at Amazon that is related to natural language. And what I'm going to be talking about today are services that fit at the top of this stack. You've probably seen this stack quite a few times today. We're operating at all levels within Amazon. What you just heard about from Julian was really spanning the platform services and the low-level topics of frameworks and interfaces and compute resources. But for the purposes of this session, we're mostly going to be talking about prepackaged services, these application services that you can see at the top here. And what you're doing with these higher-level services, with these prepackaged services, is you're taking advantage of deep learning capabilities that have been built and models that have been trained by Amazon that are then presented to you directly as abstracted service offerings. So you don't need to worry about the heavy lifting of building and training models. But of course, you can also build your own NLP, your own natural language processing capabilities by using these lower-level services. And I have one of those myself. I'm not going to really cover it in this session today, but I've used the same kind of approaches that you might use for sentiment analysis to build a popularity predictor for social media posts, where I can basically run through things that I intend to post on social media, and it will classify those posts and tell me whether or not I'm going to get good engagement or not, which is why I hardly tweet anymore. Okay, it's a joke. Okay, so I do have that system up and working. It's built using those low-level components. Let's just quickly take a tour of what we have in that top set of services for natural language processing. Then we'll return and dive really deep into this Amazon Comprehend service. So, jump forward a bit. So the first thing we have is Comprehend, which I mentioned before. We're going to spend a little bit more time on this. This allows you to discover insights and relationships in text using pre-trained neural network models, deep learning models. You can give it spoken language. We can do things like detect what language the content is in, and then we can go beyond that in English to do things like entity extraction, key phrase extraction, and sentiment analysis. And we can do that either with small text fragments on a real-time or batch basis, or smaller text fragments on a real-time or batch basis. So that is a synchronous API, which I'll talk about more later, where you submit content and you immediately get a response back saying, this is the nature of the content that you've submitted. Or we can do it on a batch basis. And on the batch basis, we're talking here about topic extraction, categorization of topics. Okay, so this is unsupervised machine learning. You can give us a corpus of written materials. We will figure out what topics are common across those written materials, and we will then categorize the documents into those topics with a confidence score, with a confidence level associated to them. So you could give it a corpus of news articles, a load of books, for example, and then we can pull out those news articles are about these topics, categorize each article into those topics, and figure out how certain we are that that article relates predominantly to that particular topic area. So topic discovery and categorization. Then we have a service called Amazon Transcribe. This accepts audio, so you are giving it either an audio stream or an encoded audio file in the form of an MP3 file, for example. We'll ingest that, we'll apply a model to it, deep learning neural network, trained model to it, and we'll convert that into the written word. So you give us audio, and we return back to you text. Okay, so that's the second service. The third is translate. This is using the same kind of sequence-to-sequence neural translation approach that Julian talked about in the prior session, but this is a managed service for text translation. We currently support English and 6 other languages, including simplified Chinese, Arabic, French, German. There's one other that I've forgotten, Italian, I think. Okay, and you can give us text in either one of these languages. We can convert it to English or convert from English to those other languages. And this is something that happens in near real time. So you shoot us the text, and within a few hundred milliseconds, you'll get back the converted text in the other language, other half of the language pair. So it's something that you can use within mobile apps. It's something that you can use within chat apps. It's something that you can use within web applications in near real time to enable you to expand your applications to target other markets beyond English. Okay, that's a very common use case for this service. Poly, you can think about this as the reverse of transcribe. So you give us text, we generate high-quality audio of the spoken word. Here we support 27 different languages, almost 50 different voices. So if you look in the English languages, for example, we have adult, male, and female, plus children, male and female children. It's a very sophisticated service, actually, very simple to use. You can just give it text and get back speech. But you can also exercise fine-grained control over things like pronunciation, volume, the cadence at which the language is rendered, so you can speed up or slow down the spoken word for dramatic effect or to meet the needs of creative objectives that you might have with speech. And I think you can guess here that the use cases extend well beyond simply converting interfaces from text into voice, but also into the creative space, such as rendering books or rendering audio for video in a way which is expressive, conveys emotion, and allows creators to automate aspects of the creative process as well. It's used in a variety of different use cases for that reason. And then lastly, my own personal favorite of the service family is Amazon Lex. This is probably best described as a service for building conversational interfaces, either with the spoken word or using text-based chatbots. So it's kind of similar to the capabilities that are provided by the Amazon Echo, but it is expressed as a web services API. So you can take these conversational interfaces into the places that your users or customers already are. You can integrate with Facebook Messenger to create automated intelligent agents that reside on the world's most popular social networking platform, which I may show you later if we have time. And you can also take voice-based experiences into the physical world. You can have a button in your mobile app that allows your customers to interact with your service using voice just by pressing to talk, issuing a statement or command, and then your mobile app can speak back to the user. Okay, so this is integrating Amazon Lex together with the AWS Mobile SDK service that we've got called Amazon Cognito for mobile identity management that makes it really easy for you to integrate these voice or chat applications into existing mobile apps, as well as running them in text form on popular social networking and messaging platforms. So it's a really good way for offering a more expressive interface to your customers. You might use it in safety-critical environments where users can't use a keyboard or be distracted. You might use it for accessibility purposes to reach users that can't type or that can't interact with a computer because they're disabled, for example. So there's a ton of cool and interesting stuff that you can do with this service. Okay, so that's the portfolio. Now we're going to get into comprehending a lot more detail. And I'll say at this point, I hope you like Python, because lots of the demos are written in Python, which I'm going to show you. So why is this interesting? Why are customers seeking to glean more information from the written word, okay, or from the transcribed written word? Answer to that is user-created content is very popular. The development of very large bodies of content is also increasingly becoming a factor where organizations want to sort, index, and improve discoverability of their content using techniques like semantic search, where I'm not searching necessarily with free text, but I want to prioritize and structure my search data in a way which allows me to pull out content which is more relevant for a particular user's needs. So being able to figure out the important parts of text, the context of text, the sentiment of text, it's becoming increasingly expected amongst users that applications will have features like this. Also, in these large-scale social platforms, it can be cost prohibitive to implement manual content moderation. So the idea that you can detect sentiment automatically, maybe even have models in the future that are trained for things like abusive language. It's really important to operating these services at scale with low costs, right? If you want to do that with people, it becomes expensive and risky. If you've got algorithms that can service some or all of that activity for you, it can dramatically reduce the costs of opening up services to much larger user bases as well. So there's a lot of interesting stuff in here. Why is AWS a good place to do this? Well, there's an ecosystem of tools around text analytics within AWS that can help you both establish corpuses of content that you want to analyze in a cost-effective and efficient way, and also build applications using other AWS services, like AWS Lambda, for example, as a mechanism for triggering text analytics. You could integrate with things like Amazon Aurora, insert records into your relational databases that might have textual content in them, trigger Lambda functions when you do so, gather information about what's in that text, and what the sentiment might be of that text, and then enrich that back into your relational or non-relational data model using this broad ecosystem of services that we provide, which you can integrate with the NLP capabilities. So it's a really interesting tool to slot into this broader ecosystem that we have. It's actually quite difficult to do this. I've learned this myself with my own small-scale experimentation with NLP for my engagement predictor, my Twitter engagement predictor. And what I've learned, actually, is exactly this. You need to collect data. I was able to do that using Twitter's CSV export, so I end up with a load of CSV files. Now, those CSV files are not infallible. When you gather the data from a data source, as I've discovered, there's data that needs to be discarded, there's data that needs to be cleaned, there's data that needs to be deduplicated. So you have that prep activity that you need to do. And I've got a third of my Jupyter notebook, which is involved in my model building activity for this NLP service, is basically devoted to cleaning up issues with my data set. Then I have to run my NLP model. In this case, I'm using XGBoost in my own implementation inside SageMaker. So I've already offloaded a lot of the heavy lifting. But there's a lot of trial and error, a lot of experimentation with that model. How many epochs or iterations should I run through my data set? Is XGBoost the right algorithm? How deep should my trees be? There's a lot of hyperparameters there and characteristics of the model building process that are really rules of thumb that experienced machine learning researchers and NLP practitioners will develop over time. I've had to do that myself, and it's taken me weeks to get a model that I consider to be a good model at predicting engagement. Okay? You don't have to do that with this service. You can go directly to sentiment analysis, you can go directly to topic extraction, and you can avoid all of that heavy lifting, all of that repeated work in establishing your own models. So it's just a much simpler way to access these kind of features. And I can tell you that from my own experience. It is definitely time-consuming and cumbersome to build these models, even if they're relatively small scale for specific use cases. We support all of these use cases, which I mentioned earlier, and underneath it, you've got deep learning infrastructure with pre-trained models. Essentially, what you can do on text analysis is submit blocks of text to the engine, and then we'll do entity, key phrase, sentiment, and language analysis for you. Okay, so we'll pull out the named entities and the entity types. We'll pull out key phrases within the text. We'll sentiment analyze and give you back sentiment scores with polarity. How confident are we that this is positive, negative, or neutral, for example? And we'll also do language detection, and here we support almost 100 different languages. For these features, it's English only today, okay, but we will bring other languages in due course. So you can use it for waterfall-based assessment, where you might send a piece of text to the API, figure out whether it's English or another language. If it's English, you've got automated processing features. If it's another language, you can route it into, for example, a contact center or a pool of workers with language skills that can do the assessment for you manually and return back the same metadata. Okay, so you have a way of using waterfall-based approaches to analyze the majority of content and then filter out content that might require manual intervention. In topic modeling, which I talked about earlier, we have an unsupervised learning capability there. You can point Amazon Comprehend a large corpus of documents, which you would typically store within Amazon S3. We will ingest the corpus. We will, in an unsupervised fashion, determine what the most popular common topics are in that corpus of documents, and then we will reassess the documents and score them for relationships against those top 20 or 30 identified topics, okay? And you can specify the topic depth that you want to extract. So here you can see keywords, and here you can see relationships to topics with, again, polarity or confidence scores that are included there. Shall I show you this in the console quickly? So, who's never seen this AWS console before? Okay, that always happens in Israel. When I do this talk in London, I can tell you like 40% of the hands would go up with people that have never used the console. Come to Israel, you're lucky if you find anybody that has never logged into it. It's great, absolutely great. So Amazon Comprehend, the console is here. And we have our getting started API Explorer. So there's two different things you can do here. Topic modeling is available in the console. It's available in the console because it's something that we envisage most customers will do on a periodic basis. It's not something that we think many customers will do regularly. You're going to have your corpus. You're going to want to model it. Maybe a few weeks or months later, you'll get another corpus, and you'll want to run that. So we think that most customers will use topic modeling via the console, but you can also drive it through the API, of course. Okay? The API Explorer, well, we think that most customers will interact with the text analytics capabilities using the API or one of our SDKs, and I'm going to jump onto that quickly in a second. But you can also experiment with the service via an API Explorer within the console. So let's get some text. Okay, you know this guy? So let's grab Boaz's biography off the AWS website, and we'll run that through and analyze it. Okay, so what have we got in there? We've got a person, Boaz Zinnerman, with 96% confidence. We've got two organizations, Amazon Web Services and AWS. We've got a person, and we've got a location. This is a miss, actually. Should be Israel, Israeli. 52%. Maybe it thinks we've misspelled Israel there, and that's why it's not so confident about the fact that that's definitely a location. Okay? And then we have our key phrase extraction, which you can see underneath, and our language, which is English in this particular case. And we think it's neutral, which means, you can see here, sentiment, 97% confident that it's neutral. That's actually correct. Most objective text, which is statements of fact, okay, is neutral in tone, so that is accurate. There's a little bit of positivity there, okay, and then we're definitely not negative, and we're very confident that we have neutral sentiment, so we have nothing on the mixed confidence factor either. And that's it, really. Very, very simple to use. You can paste whatever text you want in there. It will language auto-detect. If it's Spanish, you can do the same kind of analysis, and obviously we support English there as well. Okay, so how do customers use this? A lot of usage has been in the area of customer analytics. So reviews, email, social media, anything that involves gathering feedback from customers, you can use that to score and identify those items of feedback that you need to do something about. Might be promoting the good ones, if you've got the time for that, but definitely dealing with the negative feedback in a proactive way and making sure that you address it. allowing you to focus your service resources, your customer service resources, on the area where they can have the most impact. That's a big area of use. Semantic search, which I mentioned earlier, it is going beyond simple free text search of the type that you might get with Elasticsearch or Solr, and into structured search, where you're extracting structured data from unstructured text, storing that in a secondary index, usually in the same tool, so grabbing your metadata and putting that into Elasticsearch or Solr, for example, and then searching that in a structured manner to enable you to get all of the negative reviews about Tel Aviv, for example, combining sentiment and entities together and enabling you to focus down with structured semantic search about content which is relevant to you and your use case. And then knowledge management and discovery. This is the unsupervised topic assessment and categorization use case that I've talked about a little bit already. How does it integrate into other services? It's very common for customers to ingest documents or content in real time using Comprehend, store the original documents in Amazon S3 and generate links for access to those documents, and then index or process the links and the document metadata using services like Elasticsearch, Amazon Kinesis plus Lambda, potentially on the end of it, structuring that into Redshift or Aurora, or even building graph database capabilities inside things like EMR, or inside our new service, Amazon Neptune, for establishing graph databases. So as I said before, one of the major parts of the AWS value proposition for text analytics is the fact that it sits inside an ecosystem of other services that you can combine together with Comprehend to build sophisticated application workflows to enable you to build solutions for the actual use cases that you want to fulfill. And then similarly, this is using transcribe. So we gather our audio input, deposit our audio files on S3. We've got a Lambda trigger, which is fired each time a new audio file is deposited into a nominated bucket or prefix. Then we're firing transcribe and translate, comprehend, storing those results in Athena, and gaining our visualization capability with Amazon QuickSight. Same thing. The NLP capability sits within a broader workflow. So, what about the developer experience? APIs. Detect dominant language and batch detect dominant language. This is the first part of that waterfall model that I described, where we're going to give a fragment of text or a document and receive back a scored assessment of what the most likely language from that list of almost 100 languages is. EN or ES, English or Spanish, we can then take to the second stage. Anything else we can tag as such and process manually at this stage. Then we have detect entities, detect key phrases, and detect sentiment. And those are, again, going to accept a fragment of text or a document, and here we'll do entity extraction, key phrase extraction, and do our sentiment analysis at work, and give back our metadata structures that contain the results of those API requests. Note that there are batch and single entity versions, single execution versions of all of these APIs. Batch can take up to 200 requests in one payload, okay, and we'll give you back a data structure with a larger payload. And then on the asynchronous, we've got our topic modeling. You want to take a look at some code? I'll show you some worked examples of these different API calls. Okay, so here we've got some sample data for sentiment analysis, okay? Cell C, is that spelled right? Yeah, maybe. And here we have a code sample for sentiment analysis, which uses the batch API, okay? So when calling this batch API, we need a list structure, which contains all of the text fragments or documents that we want to submit for the batch operation. Okay, that's where we stack up our list. And all I do here, obviously, is open a file, read those lines in from the file, append them into a list structure, and then generate my client, generate my response by calling the batch detect sentiment operation on that client object that I've generated. Then I'll get my response back, pretty print it, and then down here what I'm doing is matching up the sentiment analysis against the item indexes in the original list that I built, so I can pretty print something which shows the score for each item. And there you'll see our original input is now scored, okay? So that's an example of batch operation on that sentiment analysis API. It was bad, negative 74%, amazing, positive 63%. The temperature is 22 degrees Celsius. It's an objective statement, so it's neutral with 95% certainty, okay? You can use that in your applications. I actually have that built into an app right now, which is an app for the back end for a chatbot. Let's just see if I can get this working. I may be able to. It was a little bit temperamental earlier due to latency on the network here, back to my dashboards. So let's just see if it'll work on the wired network. It may do. No. Just fix this 1 second. So Abby's going to get excited now because I'm opening the Container Services Console, my client. Yeah. Okay, I've got a task in here which is running a proxy. I just need an address from that proxy so that I can show you this demo, which I'll just grab here. Okay, it's working on the wired network. Just take just a second to load this. So what I have here is a Kibana dashboard that includes a data set around feedback on presentations that have been given over the course of this year. And I've got sentiment analysis integrated into that as part of my workflow. So if this is an example of how you might build this into a real app. So if I look at year to date here, these are all feedback results that I've got from talks that I've done over the course of this year. What happens here is you're interacting with an Amazon Lex chatbot, and you're essentially asked to provide feedback or provide a score on a session, okay? And you can give free text feedback as one of the workflows. I send that free text feedback over to Comprehend using a Lambda function and enrich the result back into the record, which is stored about that particular feedback item. And you can see that I have my feedback scores in here, and further down in this visualization, you'll see that I have the raw data that comes out of my results. It's funny. Amazon Comprehend is not a skateboarder or a snowboarder. So it doesn't know that when something is sick, it's actually good. Okay? So it thinks it's negative. So maybe I need to tweak the model a little bit there. That's quite a good example. Okay, second demo is on topic extraction. Sorry, is on entity extraction. Okay, so I have a detect entity example here as well, which I'm going to run. There's a different example file for this, which has different text in it. So I love Tel Aviv. It was lovely weather today. I'm learning about AWS. CEO of Amazon is Jeff Bezos. Same thing. It's batch-based analysis. So I get my other terminal. My other terminal. Okay, and you've got a different structure which is coming back here, which you'll hopefully recognize from that quick console demo that I showed you before. So for each line, you're getting back a structure like this, okay? And what we're saying is, begin offset is 7, end offset is 15. So if I look back into my example file, you should see that at character 7, you've got the T of Tel Aviv, which is correct. So 1, 2, 3, 4, 5, 6, 7. Yeah, so that's the word, including the space around it. And then the score, the type, and the text, which is represented by that particular entity. Dates, organizations, and people. So this is how you can build it into your app using the same approach, calling our API via one of our SDKs, you'll receive these structures back, and then you can obviously manipulate those, pulling out the relevant parts of the structure, inserting it into an index, or inserting it into a relational table, or including it in other business logic that you might have implemented within your app. And then for the single examples, you'll see there's nothing really different about this. We've got our text, in this case, embedded within this particular example. We're calling the detect entities API, and because we don't have batch as a prefix in the API method, it's expecting one entity. It'll return a data structure for just that one entity, and obviously we don't need to construct our list. We're just sending a string in this particular scenario in the request object. I'll just run that example for you as well. And here you can see that we've got several different items embedded within the request that we've made. So we've got a location, Tel Aviv, Israel, an event, the AWS Summit. So it's trained to understand quite a few different entity types and an organization. And if we just cut and paste that same piece of text back into the console, you'll be able to see that in the Visual Explorer as well. Back to comprehend. So this reflects exactly what you saw within the API response, but it's reflected and rendered, obviously, inside the Console Explorer. Okay, and then on the batch, the async APIs for topic modeling, there's an example here which shows establishing a topic modeling job using the AWS CLI. You could equally well build this one using one of our other SDKs. And here you can see we're specifying the number of topics that we want to return, a job name, a region within which we wish to run, and then we're going to provide a CLI input JSON file in this case, which includes information about the input and output locations for the data, and also includes a data access role ARN, which is a IAM role with appropriate permissions on the S3 resources that have been referenced there. So the comprehend service will be able to reach into the S3 bucket that is specified, gather the corpus of documents, batch process those, doing the modeling operation, and then it'll deposit the output in the specified location. So having the appropriate permissions on this is obviously very important. The job will fail if you don't have those. And then once you've done that, you can run this describe operation, and that will tell you that the job is in progress until the asynchronous operation is complete, at which point it'll report complete, and you'll then be able to view the output in the designated output location. So we envisaged, as I said earlier, this being a periodic, intermittent, batch-based operation that customers will run. But of course, you can integrate it with other AWS services or use our SDKs to automate it if you wish to do so. Okay, some customer examples. I'm going to talk across all services here that I covered at the top of the session, just to give you a flavor for how customers are using these services. Comprehend, we've got a customer called Infor, who are a full-service ERP suite vendor. They provide ERP software and other business software that is focused on particular vertical markets. Okay, so you'll find they've got lots and lots of stuff for retail, hospitality, manufacturing. And of course, in quite a few of those environments, customer sentiment is really key. If I'm a retailer or a hospitality business, well, you could say that in the hospitality business, hospitality runs on sentiment. You know, if you're, who doesn't use a service like TripAdvisor if they're thinking about taking a holiday? Okay, so you can see there that understanding how your customers feel about you in this particular industry is absolutely key, because we all make decisions based on what other customers write. And the only way you're going to improve perception in your company is to work on the basis of feedback that you get. And Infor provide the capability for customers in these sectors to use sentiment analysis to pick out those negative reviews, to pick out those negative customer service experiences that customers might be having, and to provide additional governance for inspection and rectification of these service issues. Okay, it's a really important use case, and it really drives to efficiency for customers being able to spend their time dealing with the customers that are unhappy, okay, or identifying the ones that are really happy and trying to get them to be advocates. It's a really important use case. With Lex, we have HubSpot. They are providing a conversational UI for social media management. With Duolingo, they're using Amazon Polly to power their language education service. Okay, so this has massively enabled Duolingo to expand the vocabulary that is available for users of their service. They used to get voice actors to speak all of the words that are involved in delivering the educational experience, which means as the vocabulary gets bigger, the costs just escalate and escalate and escalate. With Polly, for the 27 supported languages, they have a near unlimited vocabulary now that they can render into audio and use within the app. And they can also use it on demand. So if a customer says, how do I say X or Y, they can deliver a customized rendered vocabulary component for that particular use case, for that particular customer who wants to understand how to pronounce whatever that word might happen to be in that language they're learning. With Incentia, they're using Translate as part of a pipeline, and with RingDNA, well, you probably guess, they're in the call management and automation space. They're using transcribe to capture audio to enable their customers to provide or benefit from transcription services that are associated with call and contact center services. I'm sure you can think of a ton of other situations in which you might put these applications, put these services to work in your applications and businesses as well. Okay, that's it. I'm done, and I'm early. So I will stand over here and take some questions if anyone has any questions. Thank you very much for joining this session.